Hello, everyone. Welcome back to our math channel. Texas Little Apple is here. Our math class starts right now. In previous video, we broke down the massive topic of functions into the top 5 essential concepts, which every student needs to master. We move away from confusing textbook definitions, and use the function machine analogy to make these rules stick. Today, we're going to break down inverse functions, using 5 core ideas that work every single time. If inverse functions ever felt confusing or mechanical, this video will fix that, because we'll focus on why they work, not just the steps. First rule, an inverse only exists if the original function is 1-to-1. That means every output from the original function must come from exactly one input. Why? Because when you reverse the process, the inverse needs to know precisely which input produced that output. If 2 different inputs give the same output, the inverse breaks. No guessing allowed. Let's compare a function and its inverse using the same machine idea. The original function is y equals 2x plus 1. You start with x, multiply by 2, then add 1, and out comes y. Now run the machine backwards. The inverse takes y as the input, subtracts 1, then divides by 2. That gives x equals y minus 1 over 2. Same machine, opposite direction. That's exactly what an inverse function does. This is one of the most important ideas. When you take an inverse, the domain of the inverse becomes the range of the original. The range of the inverse becomes the domain of the original. Think of it like flipping the input and output doors of a machine. Every value that used to come out must now be allowed to go in. Here's how domain and range swap for inverse functions. Start with the original function, y equals the square root of x. You can only input x greater than or equals 0. And the output is also y greater than or equals 0. Now reverse the machine. The inverse is x equals the square of y. So the domain of the inverse becomes y greater than or equals 0. And the range becomes x greater than or equals 0. Same values, just swapped roles. That's domain and range for inverses. In the original function, you choose x. The function determines y. In the inverse, you choose y. The inverse determines x. So the roles of independent and dependent variables are completely swapped. This is why we interchange x and y when finding an inverse algebraically. You're not doing a trick, you're reversing cause and effect. In the original function, y equals the squared root of x. You choose x, that makes x the independent variable. The value of y depends on x, so y is the dependent variable. Now reverse the process. In the inverse function, x equals the square of y. You choose y first, so y becomes independent. And x now depends on y. Same relationship, reversed roles. That's independent and dependent variables in inverse functions. This is the horizontal line test, which tells us whether a function has an inverse. Start with a simple function, f, x, equals x plus 1. Any horizontal line hits the graph only once, so it passes, an inverse exists. That inverse function is g, x, equals x minus 1. Now look at f, x, equals the square of x. A horizontal line hits this graph twice, so it fails, no inverse. But if we restrict the domain to x greater than 0, each horizontal line hits once, and the inverse function, g, x, equals the square root of x, exists. That's the horizontal line test. The best way to remember inverse functions is this. It's the same machine, running backwards. Original function, input process output. Inverse function, output reverse process original input. If you remember that idea, every inverse problem becomes intuitive. If this clarified inverse functions for you, leave a comment and let me know. And if you want more concept-driven math explanations, subscribe for the next lesson. Next, we will show you how to solve function problems step by step in a series. Be sure to come back to this channel for future updates. Thanks for watching, see you next time.